So, what is an application made of? It is made up of forms, reports, and queries. This is what goes into making an application using a DBMS. The forms, this is the way we interact with the computer, and the database interacts with the users. This is used to read, insert, modify, and delete the data inside the database. A report is what we are going to use to get that information out to the end user. This is going to show data in a structured context. This is what's going to be changing the data into information. This also may include computed values. There's an awful lot you can do with the reports, and the reports are going to be able to then put the data inside of some way, a meaningful way of presenting it. And then we're going to have queries. Remember, we talked about the SQL language, the SQL, and we're going to be using the structured query language to create questions for the computer. This is the means of getting answers from the database. If I wanted to ask the database, give me all of the students that are in section 1 of this course. If I wanted to do that and get that information out of the database, I would have to write a query to do this. Now, you're sitting there and you're thinking, well, wait a minute, why can't you just ask Siri? Why can't you just ask, instead of writing this SQL, why can't you simply ask the computer? Well, here's something you might not be aware of. All you're doing is when you ask Siri or you ask Amazon, you ask any of these computers for information and you're speaking it, there is a program that is a natural language translator that translates your spoken words into an SQL query. That's how it works. So when you say something like, hey Alexis, where's the nearest Tim Hortons? What happens is that's translated into an SQL statement. That query then is presented to the database that stores all the locations of Tim Hortons and then comes back with the answer. So you're sitting there and you're using natural language. How come we can't use that? That's because it translates down into, and for you to understand and be able to actually use a database, you've got to be able to know how to do that intermediary step. You need to know how to create that query, that question for the computer. So a database application programs, again, created the forms, the reports, the queries, working for a standard function. When you're looking at creating an application, you're asking, what do I want this application to do? What is it that I want this done with the data? Application programs provide a more robust information. Just looking at the raw data, unless you're able to do patterns in your head, you're not going to be able to change that data into information. An application is going to do this for you. It's going to process the logic specific to the business need. I need a listing of all of how many people in North London have bought my product. So by doing this, it's going to process that data and turn it into information. This enables databases also to process over the internet. Remember when we started this and I said databases are everywhere? How then are we going to be able to use the internet as the bridge between the end user and these databases? This serves as an intermediary between the web servers and the database. It responds to events. You go on to Facebook, you go on to Amazon. What you're doing is you're creating a series of events through the application. And believe it or not, that's all your window is. When you pull up your browser and you go to Amazon.ca, that's an application you're presented with. Those are forms. Through those forms, you're interacting with the database, and this data is being sent back and forth through the internet. That data is being sent back and forth, by the way, through XML. This is another reason why we're studying XML, because it's the language of data transportation over the internet. This then will read, insert, modify, and delete data. You go and put an order into Amazon, that's nothing more than you sending data to that computer and that computer processing that data that it got sent. So how does this work? We have our end users. We have you and me. We open up a browser of our choice, Safari or Edge or whatever one we're using. And what we're doing then is we're connecting to the internet. Connecting to the internet, The end connection to that is a database management system. Regardless of what the program is, through the internet, on the computer, we are going and using an application. You want a good example of this? Every time you go onto OWL, this is exactly what's happening. There's a computer in the basement of Stevens and Lawson, the big building with the tower at Western. In the basement, there is a computer running a computer program called OWL. And so this application is running on this computer along with many others. You as the user open up OWL. Through the internet, you're saying, I want to go into this database management system and open this application. And that's exactly what's happening. OWL, like everything else, is nothing more than a database. So by you opening your browser and putting in the URL of OWL into there, through the internet, that request goes through, connects to the computer under Stevens and Lawson, and says, run this application as me as the end user. So what's the difference between an enterprise DBMS and a personal? There are two levels of databases. There's an enterprise DBMS and a personal one. And as you can imagine, the main difference is going to be number of concurrent users. And by concurrent users, it's not total number of users possibly that could go on to that, but at any given time, what's the maximum number of users that are going to use this DBMS at this moment? If it's a lot of users, you're going to need an enterprise DBMS. Processes large organizational and workgroup databases. Things like Facebook, things like OWL, things like Amazon. These require heavy-duty database, being able to handle multiple transactions at once. It supports many users and many different databases. Examples of an enterprise one, IBM's DB2, Microsoft SQL Server, and Oracle's database, believe it or not, called Oracle, are examples of enterprise DBMSs. These handle large number of concurrent transactions. What you also then have is personal database management systems. And as you've imagined, what this will handle is less number of concurrent transactions, less number of users currently on there. We're talking about this is designed for smaller, simpler database applications. Again, it's no less robust, not that many less features. You can do an awful lot with a personal database management system. It supports fewer than 100 users and 100 concurrent users. And again, that's important to understand the distinction. If I have an organization that's got 3,000 employees, and I'm building an application, but I know that at no given time will on average any more than 50 employees ever use this, I'm going to go and I'm going to create this through a personal DBMS. Because a personal DBMS doesn't have all the overhead required to handle multiple large number of concurrent transactions. So this is faster, it is quicker to use. So what I'm going to do is looking at something like this, a personal DBMS, that's kind of a misnomer. Many companies that I know, that I'm aware of, use Microsoft Access a lot of times to create applications if they know it is going to be aimed at this type of use. There used to be multiple personal databases. Used to be R, used to be Borland Paradox, used to be a number of these. Firefox, or FoxPro, excuse me. All of these used to be personal databases. And in the end, though, there really is only one left standing. Microsoft Access is pretty much the only personal database left out there. But again, just because we call this a personal database, as you're going to see, there's an awful lot of utility inside of that. Using relational model used for standard processing of database, just like the big sisters do. And because of storage and processing technology, it was not a natural fit with business docs. The fact is that there are limits. Now the limits, when you're looking at something like this, are in the gigabyte range, but when you're looking at companies and organizations that store data, this actually turns out to be quite small. So, no longer being used, The textbook says this, and again, my personal experience goes beyond that. Again, I know multiple organizations, multiple large companies that'll still use Microsoft Access, again, because less overhead, it is a faster application with small number of users, it is still as powerful. So I'm going to disagree with the textbook on that. You'll never be asked one way or the other. But as you walk out, and I think when you get into business yourself, you're going to be surprised how many times you will run across a Microsoft Access database application. There are also non-traditional types of DBMSs. We're looking at this, and there's a NoSQL database management system that's out there. The idea is now, as data has gotten larger and larger, and again, we'll be talking about big data and the fact that through the internet, we're collecting a mountain's worth of data daily. We're looking at this, and SQL is no longer efficient at going through and querying or asking the computer questions. When you're talking millions and sometimes billions of records, trying to go through them with a standard SQL is not being successful. So now we're looking at a database management system that's a NoSQL, or non-SQL in base. It's non-relational, it has a high transaction rate, and it has simple data structure. And it has no ACID support. It is not supporting the type of transaction that goes behind a relational database. Looking at this, MongoDB, Cassandra, Dynamo, these are examples of non-SQL databases that are out there. Now looking at this, we also have new SQL database management systems. These are high transaction rates, and what it does is it uses different types of algorithms to still use SQL in order to go in and use the data. This does have ACID support. It is looking at the data as a relational organization. It may or may not be relational in nature, but in most cases we're going to find that it is. Many players in the market now, more are coming, more and more people are trying and looking at different algorithms, different ways of looking at and utilizing this big data. Now, non-traditional types looking at this, there's in-memory DBMSs. And in-memory DBS, it processes it in main memory. It looks and it tries and will only process the data, load it into a main primary memory area, loading everything into RAM, working with it in that area. This is usually relational though. Again, the idea there is that primary memory is much faster. There's not the seek time. There's not going back into secondary memory and retrieving. So it's quicker. So we're able to do large amounts of data still using SQL Server or SQL. SAP HANA high volume ACID support with relational query processing. Tableau software's proprietary in-memory DBMS using an extension to SQL. And again, the textbook goes into more of detail in this, but basically what we're saying is we are using a different way of going and saying, how are we going to streamline if I'm asking the computer to give me every customer in South USA. What it's going to be able to do is go through and section out and find a quicker way. Instead of going and querying every record, there's going to be a way of processing patterns using this. So will these new products ever replace the relational model? And I can pretty much say probably not. At the end of the day, looking at being able to use data efficiently and effectively, you're really going to need to have relations between these tables. There has to be some way of connecting the data from one table to another, and relational connections is still the best game in town. So these new products probably will never replace this. We need to look at better ways of using the relational model. The conversion is also normally expensive and very disruptive. If I'm turning around and I'm Amazon and I want to go from a relational database model to a non-SQL, for example, how long will I be down? Will I do this in stages? Would I be down for a day or 3 days? How much business would a company like Amazon lose being down for 3 days? So NoSQL products are very technical. They require a deep background in computer science to use. Because again, what you're using is an algorithmic base in order to turn around and use the data in a different way than we've ever looked at data before. This takes a skill set that is just now being developed. Non-SQL impact on DBMS product in the market. Database software is expensive and it's viable to new entrants. Or database software experience is viable to new entrants. Basically what you're saying there is that there is going to be a place for looking at this and be able to use big data in a specific way. And that ends our introduction to databases, end of part 4, and end of this section.